Find the remainder when p of x cubed plus 3x squared plus 3x plus 1 is divided by x plus 1. So we name the polynomial of p of x, which is x cubed plus 3x squared 3x plus 1. Now p of x is divided by x plus 1. Let the remainder be, say, r1 or r. Now to find r, we have to do r plus 1 equal to 0, r equal to minus 1. So p of x will be equal to x cubed plus 3x squared plus 3x plus 1, and we need to find p of minus 1. This is minus. So wherever there is x, we have to put minus 1. So this is x cubed 3x squared 3x plus 1. So where there's x, we put minus 1, minus 1, minus 1. So minus 1 raised to 3. Remember, 3 is odd, and minus raised to odd is always minus. So this will be minus 1. Now next one is minus 1 raised to 2, means minus raised to even. 2 is even. Minus raised to an even number is always plus. So this is 3 plus 1. This will be minus 3 plus 1. So you get minus 1 plus 3 minus 3 plus 1. This cancels out and becomes 0. So by remainder theorem, the remainder is equal to 0. Find the remainder when x cubed plus 3x squared plus 3x plus 1 is divided by x minus 1. So here we can write it as f of x. You can name it the way you want. Is x cubed plus 3x squared plus 3x plus 1. And we need to find the remainder when it is divided by x minus 1 by 2. So for that we do x minus 1 by 2 equal to 0, x equal to 1 by 2. So we have f of x equal to x cubed plus 3x squared 3x plus 1. So we have to find f of 1 by 2 to find the remainder. So wherever there is x, you have to put 1 by 2. 1 by 2. So where there is x, I will put here 1 by 2. There is x squared 1 by 2, 1 by 2. Now f of x, or f of 1 by 2, will be, in the first case, 2 cube is 8, 3, 1 by 2 into 1 by 2, 1 by 4, because 2 square is 4. This is 3 by 2 plus 1. So f of 1 by 2 equal to 1 by 8 plus 3 by 4, 3 by 2 plus 1. Here I can take the LCM as 8. So I get 1 plus 6 plus 12 plus 8. And the answer comes 27 by 8. Now 27 by 8 is the remainder. So you got to write here, by remainder theorem, f of 1 by 2 equal to remainder. That means 27 by 8 equal to remainder. That's the answer. Find the remainder when x cubed plus 3x squared plus 3x plus 1 is divided by x. So again I can do here, maybe I can write q of x now equal to x cube plus 3x square 3x plus 1. Now we need to find the remainder when it is divided by x. So here we will put x equal to 0. So what we need to find is q of 0, which means wherever there is x, I put 0. 3, there is x square, I will put 0. 3x means 3 into 0 plus 1. 0 cube is 0, 3 into 0, 3 into 0 plus 1. 0 plus 0 plus 0 plus 1 equal to 1. So q of 0 equal to 1. By remainder theorem, q of 0 is equal to remainder when q of x is divided by x. So I can say the remainder equal to 1. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus pi. So here we'll do now p of x is x cube plus 3x square 3x plus 1. Here now we have the divisor x plus pi. We put equal to 0, x equal to minus pi. To find the remainder, we are going to do p of minus pi. So wherever there is x, I put minus pi. So here is x cube, so minus pi, 3x square minus pi, 3x minus pi plus 1. Minus pi the whole cube will be minus pi cube, because you need to remember this is minus pi the whole cube is minus raised to odd, and minus raised to odd is minus. Now when you go to minus pi square means minus, remember 2 is even, minus raised to even is always plus, because minus into minus is always plus. So this would be now 3, this would be minus, so I have to do minus 3 pi square minus 3 pi plus 1. So this is the remainder. So by remainder theorem, you need to write this statement by remainder theorem. P of equal to remainder when p of x is divided by x plus pi. Find the remainder when the polynomial is divided by 5 plus 2x. So we write it as f of x equal to x cube plus 3x square 3x plus 1. Now it is divided by 5 plus 2x equal to 0, 2x equal to minus 5, so x is minus 5 by 2. So f of minus 5 by 2, we've got to do this to find the remainder. So here we take x cube, and wherever there is x we put minus 5 by 2 plus 3x square, and where there is x again we put minus 5 by 2, because we are finding f of minus 5 by 2, plus 3x, 3 into x, and x is minus 5 by 2 plus 1. So f of minus 5 by 2 will be, here will be minus 5 into 5 into 5 is 125, 2 cube is 8, This is 3 into minus 5 square is 25, here is 4, and minus 3 into minus 5, 15 over 2 plus 1, which is minus 125 over 8 plus 75 over 4 minus 15 by 2 plus 1. So LCM will be 8 minus 125, here 4 into 2 to give us 8 into 2 into 2. Here we have to do into 2 into 2, and here into 8, not into 8, into 4. Into 4, this is over 1, so into 8 into 8. So this is 150 minus 60 plus 8. When you add this up together, you get minus 27 by 8. So remainder equal to minus 27 by 8. Don't forget to write your statement. Before this, you've got to write the statement by remainder theorem. F of minus 5 by 2 equal to remainder. If R1 and R2 are the remainders when the polynomials are divided by x plus 1 and x minus 2 respectively, 2R1 plus R2 equal to 6, find the value of A. So in the first case, we have R1 is when this polynomial x cubed plus 2x squared minus 5ax plus 7 is divided by x plus 1. So let's take up this case. So R1 is the remainder when the polynomial, we'll call it P of x equal to x cubed plus 2x squared minus 5ax minus 7 is divided by x plus 1. Now let's go ahead and find the remainder. To find the remainder, what we need to do, it is divided by x plus 1. So we need to do x plus 1 equal to 0, x equal to minus 1. Now we know P of x equal to x cubed plus 2x squared minus 5ax minus 7. To find remainder, I need to do P of minus 1. So wherever there is x, I will put minus 1. X here minus, I'll put, this is square, minus 1. 5a, wherever there is x, minus 1, minus 7. Now P of minus 1 equal to, this is minus, here minus raised to 3. So minus raised to odd, and minus raised to odd is minus. So this is minus 1. This is minus raised to even. Here this is even, 2 is even. So that becomes plus 1. Minus minus plus 5a minus 7. So this now is minus 1 plus 2 plus 5a minus 7. And here we will have 5a minus 6. This is P of minus 1. But by remainder theorem, we said the remainder was R1. So I can say R1 equal to 5a minus 6. This is one information that we will need to use later. Now for the next part of the sum, we have to find out what is R2. R2 is when this polynomial is divided by x minus 2. So let's find out the remainder when the polynomial is divided by x minus 2. So R2 is remainder when the second polynomial, that is x cubed plus ax squared minus 12x plus 6 is divided by x minus 2. So let's this polynomial be q of x. So we have q of x equal to x cube plus ax square 12x plus 6, and it is divided by x minus 2. So x minus 2 equal to 0, x equal to 2. So we have q of, we got to find q of 2. So q of 2 will be 2 cube, wherever there is x I put 2. This is 2 x square, so 2 square, and this is 2 plus 6. So q of 2 equal to 8, 2 cube is 8, this is 4a minus 24 plus 6. So q of 2 equal to, this becomes 4a minus 10. By remainder theorem, this R2 is equal to 4a minus 10. So this is second. Now we know R1 and R2. Next part, they have given us this 2R1 plus R2 equal to 6. So we are going to substitute the values of R1 and R2 in this equation. We found out R1 as 5a minus 6 and R2 as 4a minus 10. And now it is given to us 2R1 plus R2 equal to 6. So let's put our values here. So we have 2, we know our R1 here is 5a minus 6, R2 4a minus 10 equal to 6. So open the bracket, 10a minus 12 plus 4a minus 10 equal to 6. So I have 14a minus 22 equal to 6. 14a equal to 6 plus 22. So 14a equal to 28. A equal to 28 over 14 and a equal to 2. So this is your answer, a equal to 2. If f of x is a polynomial such that it is divided by x minus 1 and x plus 1, the remainders are 5 and 19. Determine the remainder when f of x is divided by x minus 2. Let's read the first part again. So here we have this polynomial, and they said it is divided by x minus 1. And when divided by x minus 1, the remainder is 5. So let's write that. When f of x is divided by x minus 1, the remainder is 5. So let's find the remainder when f of x is divided by x minus 1. So we know f of x is x4 minus 2x cube 3x square ax plus b. Now it is divided by x minus 1. So to find the remainder, I do x minus 1 equal to 0, x equal to 1. And then I find f of 1. And that will be equal to 1 raised to 4. Wherever there is x, I put 1. Where x, I put 1. Now this gives me the remainder, and the remainder they said was 5. So I'll write 5 is equal to, because they said the remainder was 5, 1 minus 2 plus 3 minus a plus b. So 5 equal to, this becomes, here we have 3, so this becomes 3 minus 1, so that is 2 minus a plus b. Take the 2 on the other side. 5 minus 2 is minus a plus b, and we'll have now 3 equal to minus a plus b. We'll put this equation 1. We'll need it later. Now we'll go to the next part of the sum. And the next part, they said the same polynomial f of x is now divided by x plus 1, and the remainder comes 19. So we have f of x is divided, in this case, x plus 1 and remainder equal to 19. So we know f of x is equal to x4, or x raised to 4 minus 2x cube plus 3x square minus ax plus b. Now we need to find the remainder when it is divided by x plus 1. So we put x plus 1 equal to 0, x equal to minus 1. So we have f of here minus 1, which is equal to, wherever there is x, I'll put minus 1 raised to 4. So 2, this is x cube, so minus 1 cube. This is 3x square minus 1 square, ax minus 1 plus b. So we have f of minus 1, and the first is minus 1 raised to 4, and remember that 4 is even, so this would be now plus 1, so minus 2 bracket, and here we have 3 is odd, so this would be minus 1, would remain minus 1. So plus 3, this is minus 2, so is raised to 2, so 2 is even, so plus 1, so minus plus a plus b. So f of minus 1 equal to plus 1 plus 2 plus a plus b. Now f of minus 1, we know it's a remainder, and they said the remainder was 19 here. So 19 equal to 6 plus a plus b. So we take it on the other side, and we will get a plus b equal to 19 minus 6. So 13 equal to a plus b. This is my second equation. So we have two equations now. So one equation is minus a plus b equal to 3, and the other equation is a plus b equal to 13. Now how do we solve this? Now we'll take b. What will be b equal to? 3 plus a. So wherever there is b, I will put 3 plus a. Here there is b. So a, for b I will put 3 plus a. I got this from here. For b I put 3 plus a equal to 13. So a plus a is 2a plus 3 equal to 13. So 2a equal to 10. So a equal to 5. So I found a equal to 5. Now I need to find b. I know b here. I've done b equal to 3 plus a. So 3 plus a is 5. So b equal to 8. So I got the value of a and b, and I'll put this value back in the polynomial. Now my polynomial was x raised to 4 minus 2x cube plus 3x square minus ax plus b. I'm going to put the values of a and b that I found. A I found as 5 and b I found as 8. So now my polynomial becomes x4 minus 2x cube plus 3x square. A is 5, so 5x, b is 8. So this is my polynomial. Now for the second part of the sum, we had to find the second part, we had to find remainder when f of x is divided by x minus 2. We'll go ahead and find the remainder when f of x is divided by x minus 2. So we know f of x was x raised to 4 minus 2x cube plus 3x square minus 5x plus 8. Now it is divided by x minus 2. To find the remainder, I do x minus 2 equal to 0, x equal to 2. And now I find f of 2. Wherever there is x, I put 2. So 2 raised to 4. 2 cube means 2 raised to 3. 2 square, 2 plus 8. This is 16. This becomes minus 16. Here 12 minus 10 plus 8. Minus 16 plus 16 will cancel out. This becomes now plus 2 plus 8, which is equal to 10. So the remainder is equal to 10. The polynomial ax cube plus 3x square minus 3 and 2x cube minus 5x plus a are divided by x minus 4, leaving the remainder r1 and r2. Find the values of a in each of the following. So let's take up the first case when the polynomial ax cube, we'll give it a name, we'll say p of x equal to ax cube plus 3x square minus 3 is divided by x minus 4, and the remainder equal to, they said, r1. So let's find the remainder. So we have first p of x, a x cube plus 3x square minus 3. It is divided by x minus 4, which means now we are going to take x minus 4 equal to 0, x equal to 4, and here we will find p of 4. Wherever there is x, we will put 4. So we have 4 cube, 4 square minus 3. Now p of 4 is a remainder, so I'm going to write it r1. So this is 64a plus, this is 48, 16 into 4, 48 minus 3. So the r1 now works out to be 64a plus 45. So keep this in mind. R1 is 64a plus 45. And we go and find r2. For r2, we know the polynomial is divided by, same polynomial divided by x minus 4, and the remainder is r2. We'll call it f of x, 2x cube minus 5x plus a divided by x minus 4. The remainder is r2. Now to find the remainder, we have f of x, 2x cube minus 5x plus a. You have x minus 4 equal to 0, x equal to 4. So you have f of 4 to find the remainder now. Wherever there is x, I will put 4. So this becomes 2 into 4 cube is 64. This is 20 plus a. 128 minus 20 plus a. This is remainder r2. This is by remainder theorem. And here becomes 108 plus a. Now this is my r2. 108 plus a. I found my r1 and my r2. Now they are saying r1 equal to r2. So now we need to put the equation r1 equal to r2 We have found the R1 as 64a plus 45, and the R2 we have found as 108 plus a. So R1 equal to R2, that means 64a plus 45 equal to 108 plus a. So let's solve this. 64a minus a, this a I take on the side, and 108 minus 45. So this becomes 63a equal to 63. So a equal to 63 by 63. So a equal to 1. This is for the first sum. Now the second sum condition is given that this is the second, R1 plus R2 equal to 0. So let's do it out here only. R1 plus R2 equal to 0. Now R1 we know is 64a plus 45, and R2 is 108 plus a. This is equal to 0. So 64a and a together will give you 65a plus. Next we add 45 and 108, and that is 153 equal to 0. So 65a equal to minus 153. A equal to minus 153 over 65. This is for the second sum. Now for the third, they said 2R1 minus R2 equal to 0. So let us take up this condition. 2R1 minus R2 equal to 0. Now we know the R1 was 64a plus 45. R2 was 108 plus a, and this equal to 0. So we open the bracket. So 126a plus 90 minus 108 plus a equal to 0. So 126 and a, you get 127, and here 108 minus 90 minus 108, that is minus 18 equal to 0. So 127a equal to 18, and a equal to 18 over 127. This is the third one. Before we start the sum, let us know when do we know if our number is a factor or not. Suppose I want to know is 6 factor of say 38. What do? I divide 6 and 38. 6 6 are 36, remainder 2. So the remainder is 2. Therefore I say not factor. But suppose I want to see is 6 factor of 126. So I do 126, I divide by 6, and I do 221 and 26, remainder 0. If remainder is 0, I will say is a factor. So if remainder is 0, it is a factor. If remainder is not 0, it is not factor. We use this concept in solving this next sum. Here show that x minus 3 is a factor of this polynomial. So what I will do is first I need to find the remainder. So let me say p of x equal to x cube minus 3x square 4x minus 12. So to find if x minus 3 is a factor, we need to find the remainder. So when p of x is divided by x minus 3, the remainder will be how do we find the remainder? We do x minus 3 equal to 0, x equal to 3. So we have p of x equal to x cube minus 3x square plus 4x minus 12. We do p of 3 here equal to x cube is 3 cube. Wherever there is x, I put 3. 4 into 3 minus 12. So this is 27 minus 27 plus 12 minus 12. So this cancels out. So P of 3 equal to 0. Thus we see that the remainder is 0. So we see P of 3 equal to 0. Therefore, by factor theorem, we can say that x minus 3 is factor of P of x. Show that x minus 1 is a factor of x raised to 10 minus 1. So what we do is, first we have to find the remainder. So we have P of x equal to x raised to 10 minus 1. So we need to find the remainder with x minus 1. So x minus 1 equal to 0, x equal to 1. So we now find P of 1. And P of 1 equal to x1 raised to 10 minus 1. So P of 1 raised to 10 is 1 into 1 into 1 into 1 10 times, which is 1 minus 1. So P of 1 equal to 0. So by factor theorem, if P of 1 equal to 0, then we can say that x minus 1 is factor of P of x, and P of x, you know, is x raised to 10 minus 1. Now for the next one, here we have to show that x minus 1 is a factor of x raised to 11 minus 1. So again we do P of x equal to x raised to 11 minus 1. Here we won't take P of x, we'll take f of x, since we have already taken P of x earlier. Now again, to show it is a factor, we take x minus 1, same way, equal to 0, x equal to 1. And then we find f of 1. Wherever there is x, I will put 1. So 1 raised to 11 minus 1. 1 into 1 into 1, 11 times will be 1, minus 1. So f of 1 equal to 0. The remainder is 0. Therefore, by factor theorem, we can say f of 1 equal to 0. Therefore, x minus 1 is factor of f of x, which is x raised to 11 minus 1. So basically in all these sums, if we show a remainder equal to 0, it is factor. If remainder is not equal to 0, not factor. Show that x plus 1 and 2x minus 1 is a factor of this. So let's take up x plus 1 first. So P of x is 2x cubed minus 9x squared plus x plus 12. To show that x plus 1 is factor, what we need to do is we do x plus 1 equal to 0, x equal to minus 1, and now we find P of minus 1. Wherever there is x, I put minus 1 cube, minus 9, x square means minus 1 square, x minus 1 plus 12. So P of minus 1 equal to 2. This is minus 1. Minus 1 cube is minus 1. Here is plus 1. Minus 1 plus 12. So P of minus 1, minus 2, minus 10, minus 1 plus 12. So P of minus 1, if you see, becomes minus 12 plus 12 equal to 0. Therefore, by factor theorem, we see that p of minus 1 equal to 0. Therefore, x plus 1 is factor of p of x, and p of x we know is 2x cubed minus 9x squared plus x plus 12. Next we need to show that same x plus 1 only is factor of 2x cubed minus, so we do the same procedure. So we know p of x is equal to 2x cubed minus 9x squared plus x plus 12. We need to show that 2x minus 3 is the factor. So we do 2x minus 3 equal to 0, 2x equal to 3, x equal to 3 by 2. So wherever there is p, I will put 3 by 2, and I see what is the remainder. So 2x cube, 3 by 2 cube, 9x square, 3 by 2 square. This is 3 by 2 plus 12. So 3 cube is 27, 2 cube is 8, 3 square 9, 2 square 4, 3 by 2 plus 12. So when I cancel this, you get 27 over 4 minus 81 over 4 plus 3 by 2 plus 12. So we'll now take the LCM. The LCM will be 4. So 27 minus 81 plus 6, and this will be 12 into 4, so 48. You know why it is 48 was 1. This would be into 4 into 4. This will be into, to make LCM, 4 into 2 into 2. So this is now minus 81 plus 81 over 4. So p of 3 by 2 equal to 0. So when we use factor theorem, so we can say by factor theorem that 2x minus 3 is factor of 2x cubed minus 9x squared plus x plus 12. Find the value of a if x minus a is a factor of this polynomial. That means if x minus a is factor of the polynomial, we'll call it p of x, x cubed minus a square x plus 2. So we can say that therefore p of a will be equal to 0. So we do x minus a equal to 0, x equal to a. So first we do p of x. P of x is x cubed a square x plus 2. Now we find p of a, because they said x minus a is factor. So here wherever there is x, you put a. So a square, this is x here, I put a. There is x here, I put a plus 2. So p of a equal to a cube minus a cube plus a plus 2. Now if it is a factor, so I can say that p of a by factor theorem, or even by remainder theorem, the p of a will be 0, because if it's a factor, the remainder has to be 0. So I can say 0 equal to, this of course cancels, a plus 2. So a equal to minus 2. So here basically we found the remainder, and if it's a factor, we know the remainder should be equal to 0. Find the value of k if x plus 3 is the factor. I'll just put it here. X plus 3 is factor. That means the remainder should be equal to 0. So we have p of x, the polynomial is 3x squared plus kx plus 6. Now it's given to us x plus 3 is factor of p of x. Therefore I can say, I write here x plus 3 equal to 0, x equal to minus 3. So p of minus 3 equal to 0. This is by factor theorem. In other words, the remainder becomes 0. Let's find out p of minus 3. Now how do we find out p of minus 3? So wherever there is x, I put minus 3. Like in this case, here, I will now write, this will become 3, the x I'll put minus 3 square plus k. Now here, for x I will put minus 3. So this will be minus 3 plus 6. Now we know it is equal to 0 by factor theorem. This was given. This is the remainder what we are finding, and the remainder is 0 because it is factor. So this is 3 into 9 minus 3k plus 6. So 0 equal to 27 minus 3k plus 6. So 0 equal to 33 minus 3k. So 3k equal to 33. So k equal to 33 over 3. So k equal to 11. For what value of a is the polynomial exactly divisible by 2x minus 1? So if it's exactly divisible, means my remainder equal to 0. Let's find the remainder. So we have p of x, the polynomial p of x, which is equal to 2x cubed plus ax square 11x plus a plus 3 is divided by 2x minus 1. Let's find the remainder. To find the remainder, we do 2x minus 1 equal to 0 because it's divided by 2x minus 1. 2x equal to 1, x equal to 1 by 2. So this is our p of x. So we find p of 1 by 2 in order to find the remainder. So wherever there is x, I'll put 1 by 2. This is cube. For x, 1 by 2. For x here, 1 by 2. A plus 3. So p of 1 by 2 equal to 2. 2 cube, 8. So this is a. 2 square, 4. 11 by 2 plus a plus 3. So p 1 by 2, here we take the LCM is 8. So this is 2 plus, now in this case we will get into 2 to make it 8. This will be into 4 to make it 8, into 8 to make it 8. This is 1, so into 8 to make it 8. LCM is 8. So this is 2a plus 44, 8a plus 24. So p of 1 by 2, remember we are finding remainder here. So here when we add, we'll get 70 plus 10a over 8. Now since it is a factor, we know the remainder is equal to 0. So here I will put 0 because it is a factor, the remainder has to be equal to 0. So this will be 70 plus 10a over 8. So 0 into 8 equal to 70 plus 10a. 0 into 8 is 0. 0 equal to 70 plus 10a. So I take it on the other side. So minus 70 equal to 10a. And a equal to minus 70 over 10. So a equal to minus 7. So this is your answer, a equal to minus 7. So every time it is a factor, remember when you find the remainder, you got to put the remainder equal to 0. In each of the following polynomials, find the value of a if x minus a is a factor. So first we'll do p of x cube plus a x square minus 2x minus a plus 4 is divided by x plus a. Say let r be the remainder. So to find r, we have to do x plus a. Let's do it in another color. Yeah, I'll do it here. X plus a equal to 0, x equal to minus a. So this is p of minus a. So wherever there is x, here this is x, so this I will put a cube. Here the a would remain as a, but the a square will be a. So minus 2 here, for the x I will put a, minus a plus 4. This gives us the remainder. P minus a actually is a remainder, so this is a cube. I have to put minus a, so this would be minus, it would be plus. Remember, I've got to put minus a here. So yeah, this would be minus plus a cube, this would be minus plus 2a minus a plus 4. There's another little mistake here. This will be taken as plus a. So here will be plus a, so this is plus a. So here this cancels out. So p of minus a equal to 3a plus 4. So we know the remainder. This is the remainder what we found is 3a plus 4. But we know that x plus a is factor. Therefore, a remainder equal to 3a plus 4 equal to 0, because factor means remainder is 0. So 3a plus 4 equal to 0, a equal to minus 4 by 3. The answer is minus 4 by 3. In each of the following, find the value of a if x plus a is a factor. So again we'll do p of x is x raised to 4 minus a square x square plus 3x minus a. Now we want to know when it is if x plus a is the factor. So we have to find the remainder. So we do what? X plus a equal to 0, x equal to minus a. So here we will find p of minus a. So wherever there is x, I'll put minus a. So minus a cube minus a square. Here there is x, so I will put there minus a square. 3 here there is x, so I will put here minus a. This is plus a. So p of minus a equal to minus a cube. This is minus a square into a, minus 3a plus a. So p of minus a equal to minus a cube minus 3a plus a. Now this cancels out. Now here we have again p of minus a equal to minus 2. Here again I made a mistake, to be plus here. I think here is a mistake, this should be all minus. So let me just put, it should be minus here, therefore here also will be minus. So when we put this together, you get, now this cancels out, and here you get minus 4a. But the remainder are equal to p of minus a. So this minus 4a that we found is the remainder. And we know the remainder has to be equal to 0 because it is factor. Whenever it is factor, remainder is equal to 0. So minus 4a equal to 0, a equal to 0 over minus 4, a equal to 0. So that is your answer. So to summarize it, always find the remainder. You know how to find remainder when two polynomials are divided. Second point, if r equal to 0, it is factor. The divisor is a factor. And if r is not equal to 0, it is not factor. So everything depends on the remainder. You found the remainder then decides if it is factor or not.